Alrighty, so got a work holding problem. I want to face these guys off and get them down to size, but I want to remove all the excess material, and I want to get the scratch lines going circumferentially around the circumference rather than across as they are now from the saw cut. So in order to do that, I need some way to hold this, and the vice jaw is cut into this stuff instantly, even when you lightly hold it. So an ideal solution would be an expanding mandrel, but I don't have the material to make an expanding mandrel that big. So what I'm going to try and do is make sort of the equivalent of a jaw interface expanding mandrel, and hopefully it'll become clear as I do it. I don't know how well this is going to work, but we're going to give it a shot. So first I want to make about ½ inch, a mandrel that's about ½ inch, and I got to take this down to 3.5, so it's 3.75 right now. So I got a pretty high feed rate going on here. It's 9 thousandths a revolution, and so that leaves a little bit of grooving on here, and I actually think that'll help me hold the part better, so I'm going to leave that. I think that's going to be desirable. And remember, this piece is not even cylindrical, so I have to I probably should bevel it so that I can try and better test fit. So it's not cylindrical, so I can't even make it so I can just slide the part on. It's going to have to be sort of stretched on, so it's never going to be perfect. Fortunately, we only have to do facing cut. Okay, there we go. That'll work. Now we just need to bore out the middle till about 1/4 inch to the edge, approximately. These are 200 thousandths bites. Nine thousandths a revolution feed rate. $300 thousandths bite. Try to remember, finish isn't important for this. The inside is where the vice jaws are going to go. The outside is where the part is. That's the part that needs to be nice so it doesn't damage the surface finish. Okie doke. We just hollowed out about 3 inches of material out of the center of this to somewhat over ½ an inch deep. Next we're going to part this guy off. Always when you get in with the chip welding, it's interesting. It doesn't usually happen when the part's out. When you're cutting on the outer diameter, it's only when it's in. Must be some sort of dragging thing going on. But if you don't do something about it, you can break your tool. Ask me how I know. Isn't that amazing how a little bit of lube works? Right, I know I showed this a while ago, but if you take and you know the diameter fairly accurately of a circle, then you take the radius, which is half the diameter. So this is 3.462, half the diameter is 1.731. And then you set your compass to 1.731 with the radius, and you just walk along the outside and mark, go to the next point, use that as a reference, mark all the way around, and you'll have a circle divided in 6 equal parts. I'm going to take this over to the bandsaw, and I'm going to cut almost all the way through in all 6 spots. Alrighty, so I grooved this most of the way through. I'm not sure how much is a good amount. It looks like that one's a little shy. I'm going to go open that one up a little bit. I've deburred them on the Scotch-Brite wheel, which is why they're flared the way they are. And what I'm going to do is I'm going to pop this guy on here, stick the plastic over it and then crank this open, and I'm going to make sure to line all these splits between the jaws, and then hopefully we'll be able to grab the part without damaging it. A lot of unknowns for me here. Alrighty, so we open them up just a little bit more. Now hopefully they will be able to expand a little bit and grab the inside of this when I crank. Oh. When I crank, that was a weird sound. I hope that wasn't the scroll shifting. Oh, that's a good tight fit. I think that'll be all right. To give myself the best chances of success, I am going to attempt to take really light passes, and I've got a fresh cutter. Wow. That's a lot of wobble there. It's probably because neither side's flat. So now that I've got one side that's mostly flat, I'm going to flip it 180. Good. All right, let's see if we can clean this side up. Just kind of curious how another type of cutter I've got to work on this. It's not as sharp, but, oh, actually, is it relieved? I think it's straight. Yeah, it's relieved. So if I came straight in, I think it's, well, let's try it. Boy, it's terrible looking at that. This way I'm pushing it into the jaw as I'm cutting. This one's not as sharp. Oh, and it melted the plastic. Yeah, not as good. Definitely not as good. Oh yeah, that's no good at all. Maybe if I slowed it down a little bit, but yeah, we're gonna have to clean that up. Okay, the last pass, I'm gonna do a power feed, and I'm going to make it a very slow feed. We'll see if we can get a good finish here. I'll tell you another thing, this stuff is messy. All right, so we are done. So I would recommend this solution. This actually worked out really well. Oh, that snap I heard? I know what that snap was now. That was one of the sides that I had that was too narrow. It broke, which is, I didn't really want that to happen. But anyways, this thing worked out really well. So recommended solution. I don't know how perfectly concentric it is because this wasn't a precise operation, but it worked for my purposes here. Now, I don't know if you can see this, but you see the scratch marks now? You see how they line up in line with the circumference? That's exactly what I wanted. Hopefully that'll prevent leakage. So 6-jaw chuck. Expanding mandrel that fits on the chuck, pretty handy. All seem to work out pretty well. Here's the whole part assembled. I left more threads on the bottom. The top I'm going to probably Loctite in after everything's all assembled. Unfortunately, you can see some jaw marks on the centerpiece there, plus I screwed up the threads. So overall, a lot of disappointments, but I think this is going to work out all right. So next step is pressure test this guy and see how well it works. Alrighty, so we have our test device here, our light, inside the pressure cooker, and I've modified the pressure cooker. Over here is the pressure regulator, and I've got a hose hooked up to it. And the way the pressure regulator worked is it's this weighted piece that has 3 different PSIs, 5, 10, or 15 PSI. And the way it works is the output of this goes to a very small orifice, and it's cone shaped, and it fits inside the weight here. So the smallest opening here is 15 psi going to the largest one at 5 psi. Basically, the pressure inside lifts this weight off of the orifice when the pressure gets to the right amount and lets some steam out, and it'll sit there and go like that until, you know, and keep the pressure somewhat consistent. It's got a pressure gauge on the side. So what I'm going to do is I'm going to fill up enough water here to submerge this guy. I'm going to seal this up, and then I'm going to apply 20 pounds of pressure to the air above the water, which will make the water have equivalent of 20 pounds per square inch, and hopefully my seals will hold. Here's the first positive sign. Although this isn't salt water I've got in here, it's just fresh water. Salt water obviously is slightly more dense, which makes things more buoyant, but only by about 10%. And this thing definitely sinks. So it's not at all neutrally buoyant, so that's good. Although the top part that has less weight on it is definitely lighter, but it sinks nicely. So this is completely submerged. Now I'm going to seal this guy up and we'll pressurize it up. Alrighty, so we have the pressure here at about, oh, that's 15 psi. Let's crank it up just to the edge of caution there. And I didn't bother Teflon coating that connection there, so that's why it's leaking. So we're at about 20 psi right now, which is the edge of caution. But this pressure cooker has an overpressure safety device, so this little rubber stopper will pop out if you get the pressure too high. So I'm not overly concerned about it popping or rupturing the container. As a matter of fact, they must have designed this thing with at least double the pressure safety, you would think, at a minimum. So we're going to let it sit like this for just a few minutes, and then we're going to pop it out and see if any water got in. All right, the moment of truth. Try and do it one-handed. Hey, look at that. It's dry. I don't see any water moving around inside. It was sitting here for like 10 minutes, so that's pretty darn good. I think we have a winner. See, no water inside. Okay. Next step, mount the LED arrays, powered up, drill and tap on this side for the gland, and that might be my weak spot, the cable entrance, but at least this part doesn't leak. Hey Massimo, good boy. He's got to check out all his favorite spots in front of our house, see if anyone signed the guest book without his permission. I live on a very busy street, and as a result, from puppy on, we trained him not to go off the curb unless he heard the word street. So only twice in his life has he gone off the curb without. Both those times he was being chased by another dog. All right, so next up we got to drill a hole for the waterproof gland. And these are M16 by 1.5 threads. I thought they were NPT threads, but they're made in Germany and they're metric threads. And they're straight threads for that matter. They rely on a gasket, if you can see there. Let's see if you can see. They rely on a gasket to make their seal. See the O-ring? So we're going to drill, but I don't have a 14.5 millimeter drill, so I'm going to drill 1/2 inch and then bore the remaining 70 thousandths and make that work. I've switched to a high helix deep drilling drill bit. It's specifically designed for deep holes, and I'm not sure softer materials or not, but definitely the high helix makes the web, the center part of the drill bit, weaker, but it gives much better chip evacuation. It's a long way through this part. And we're through. It's a long way through that part. By the way, in case you're wondering, the tape's here to cover up the groove because I didn't want to clean all the lubricant I had out in there, all the petroleum jelly and the gasket, so instead I just closed it up so that it wouldn't get any chips in it. So although I'm not particularly fond of this method, I'm using calipers and these blades to measure the inside diameter and going for the max value. And it says I need 10 thousandths more. Just in case you're wondering, here's 0.571 and really tight fit. Next, tap it. At some point in time, I bought this tap online. This thing's going in really smoothly, and it's sort of unique. Let's see if you can see here. But every so many threads, they put a relief in it, probably let chips go into the main flutes. As a result, even though I'm going through over 1.5 inches of material, look at how easy this is going. No problem whatsoever. I've never seen anything quite like it. The threads are really clean too. Alrighty, so here is the central shaft mounted with the LED arrays on it. And here's the gland on the bottom that you saw me drill and tap for. It looks like it should be a good seal. Let's just hope it is. I looked at the strain relief qualifications of this thing, and the strain relief's insane. The strain relief on this is good for about 400 pounds pull. So I may not need to do anything. So I'm going to leave the 1/2 inch 20 threaded section there in case I needed to provide some additional strain relief for this cable. But in the meantime, we're just going to try it like this. And I wired this guy up. These LED arrays are 12 volt approximate arrays, and they're all in series. So let's see. I need the switching supply. I need to wire up the switching supply next. And I need to put it in a case. Now, normally these things would need lots of cooling. Let me pop this guy out of the anti-static bag. And so I've got this aluminum box, but I think I can get away without the cooling. I'm going to try and put it in this plastic box and see how it does. The LED array uses, it wants constant current, which is one of the reasons you need a power supply to feed it rather than just a battery. Because you want consistency, you need to feed it with a fixed current but a variable voltage based on temperature. So this inverting supply takes 12 volts in or 13 volts in from the batteries on the boat and outputs 30 some volts, and it's set for constant current. It's both constant voltage and constant current. I set it for about 1 amp, just a little bit over at 30 some volts, which will draw 3 amps or so at 12 volts. This inverter is good for a 600 watts. The LED arrays only use about just under 40 watts. So I'm hoping it won't get very warm and it'll survive in a plastic box okay, because I can do a much better job sealing the plastic box than this metal box. So we're going to do that next. Alrighty, so I'm going to reassemble the whole housing so I don't have to worry about the LED array getting compromised. I'm adding more petroleum jelly to it. I'm going to run, I cleaned it off when I took it out, so I'm going to put more petroleum jelly so this thing slides nicely. Can always clean it after. I want to make sure it slides okay. And I'll also be adding some to the aluminum threads to prevent seizing. And some more on the top. So if you remember on the top part here, I screwed up the threads. So the threads are so shallow now that I could actually tighten it past the end of the threads into the relief section. So I made a little spacer so that that can't happen. And the spacer gets pinched in there nicely. So that's nice and solid. So we'll put on the base. You got to get the non-round acrylic lined up every time, which is kind of a pain. But then it's all good. All right, so we are good to go. So I just got to get the power supply set up, and we'll be ready to go for a first run. There we go, nice and snug. Even though the hole's really undersized from 14.5 millimeter, I actually made it the next size standard down, which is like 80 thousandths undersize. I can just hand run the tap into this. Oh, there it gets a little stiff for just a second, and then away it goes. This is a really crappy box. I am going to find another one. This is not going to be the permanent solution. Maybe I'll get a metal bud box or something, one of the aluminum ones. These gland kit, they didn't come with O-rings, so I had some. I bought one of those inexpensive Harbor Freight O-ring assortments and had the right size. So that'll just keep most of the water out. This is never going to be submerged. This stays at the surface, but I like to keep moisture out anyways. The glands that come with these are actually a really large size range, and they do that by virtue of having a removable center section. So you pull this out and you see that this actually isn't attached. Well, it's attached just to the top, so I run a blade around there, cut it out, and that lets it deal with wire diameter that's as much as this extension cord. So you can see that supports the larger diameter range. And I know that it looks really rough up here at the top, but the bottom part of this gets squeezed so much that it really has a good hold. All right, so we got the prototype done, and I'm definitely going to order another box, get something in aluminum where I can put decent threads and actually make it water resistant, because saltwater splashing around electronics is a nightmare. Saltwater is pretty bad for almost everything. So we're going to see if we can make it a little bit more secure. All right, we're out here ready to test the light in the swimming pool. And down here is the light swinging there. And my phone is what's lighting up the area. So we're now going to power up the light and toss it in the water. There it is. About 10 or 15 feet down. I'd show you how bright it was, but since it's totally blowing out the picture, you can't actually see. So far I consider it a success. I guess if we bring it up and it's full of water, that will be not quite as good. That 1/2 inch 20 threaded portion on the top, we're actually going to attach a separate cable to it and use that to pull it up rather than the cable itself, because the PVC jacket on this extension cord is kind of crappy and I don't think it'll last very long. Anyways, that's it. There you go. Thanks for watching. Hope you find it useful. Hope to see you next time. Well, it's blowing up.